Okay, so I'm guessing either one of two things happen here. One, you know exactly what I'm talking about and what we're dealing with over here. Or two, you guys just had your minds blown by this question. I guess if you don't happen to fall under these two categories, probably means you're not interested. In which case, allow me to just ignore your entire existence for a bit here. Point is, there's something inherently off-putting about the way we use our temperature system, and I hope it's something you have noticed after I've exposed you to that question. Let's take this step by step to try and understand. I'm sure some of you have thought of some possible solutions already, and it probably involves converting Celsius into Kelvin. And it makes sense at first because you get to get rid of all the nasty zero and negative values which exist on the Celsius scale but not on the Kelvin scale. So is everything all good now? Well, no. Turns out that's not the right solution, but that's alright. We'll try to understand why that's the case, because I believe understanding why you're wrong is just as important as understanding why something else is right. Let's assume that the proposed solution is true. A temperature of 0 degrees Celsius will be equivalent to 273.15 kelvins. To make this temperature twice colder than it currently is, we're going to divide it by 2. The answer to that is 136.6 kelvins. Converting back to Celsius, we're going to get negative 136.55 Celsius. Almost intuitively, we can tell that this isn't the right answer, and this is even more obvious when we consider a different example. If a cup of water is 25 degrees Celsius, what is the temperature of a cup of water which is twice as hot? Following the same logic, we will arrive at an answer of 323.15 degrees Celsius, which is definitely not correct. So, what went wrong? Will it even be possible for us to answer these questions? Well, of course we can, because that's the sole purpose of this video. It's always helpful to compare things, and what better to compare temperature with than with our weight system. You see, everything makes sense if you think about this problem with weights instead of temperature. What's twice heavier than a kilogram? Well, that's 2 kilograms, easy to say. Twice lighter than that, and it's 500 grams. Even makes sense when we use 0 kilograms. What's twice heavier than 0 kilograms, you say? Well, it's still 0 kilograms because 0 kilograms is literally nothing, and twice heavier than nothing is still gonna be nothing. Then why does this make sense for weights but not for temperature? If you think about the way we measure temperature and the way we measure weights, we find that they're actually pretty similar. More weight, that means more grams. More kinetic and vibrational energy, that means more kelvins. If two scales work in the same way, then we know that the problem is not with the way we measure temperature, but rather we are now being led to believe that the problem instead lies in the way we define the words hot and cold. So, language and terminology is the issue here. To elaborate further, we're gonna rewind back a bit. If a cup of water is 25 degrees Celsius, what is the temperature of a cup of water which is twice as hot? Yeah, remember this part? Well, what if we were to ask the same question, but instead of using the word hotter, we're going to use average kinetic energy instead? And already the answer is starting to make, well, at least a bit more sense. See, the thing is, there's a lot of energy in a 25 degrees Celsius cup of water, but using the word hot doesn't allow us to really consider that. You see, that's because we usually refer to something that is hot as being 30 to 40 degrees Celsius. Of course, anything above that also counts. When we use the word average kinetic energy, it lets us realize that the cup of water has, in actuality, quite a lot of kinetic energy, enough to make it burn and boil if doubled. And it is this confusion between the way we interpret and understand temperature with our own language that becomes the basis of this problem. Okay, so you get it? I hope you understand. I really hope you do, because this is already my best attempt at explaining. I even put in the effort to animate and stuff, see? So how do we use this newfound information to answer the question at the beginning of the video? Well, we need to properly take the definitions of hot and cold into account on our temperature scale for all this to make sense. To do this, we need a sort of pivot, a midpoint in the temperature scale such that any value above it can be considered as hot and any value below can be considered as cold. And luckily, we have that taken care of already. To answer our initial question, 0 degrees Celsius is about 25 degrees below room temperature. To put things informally, it basically scores 25 points for being cold. Twice colder than that would be 50 points worth of being cold, which is 50 below room temperature. Hence, we reach the final answer of negative 25 degrees Celsius. Hey, if you like what you see, please consider liking and subscribing so that I can feel happy and make more videos that way. So yeah, bye.